This section explains the Neural Radiance Fields, NeRF model, and code implementation. Let's first look at the NeRF model overview. Neural Radiance Fields is a novel deep learning technique for novel view synthesis of 3D scenes. It represents a scene as a continuous 5D function that maps 3D coordinates and viewing directions to color and density values. The function is learned via a neural network. Mathematical formulation of NeRF. NeRF models a scene using a function as follows. X represents the three-dimensional position of a point. D represents the normalized viewing direction. C represents the emitted color. Sigma is the density of the point, which determines how much light is absorbed or scattered. The function f theta is implemented as a deep neural network that learns to reconstruct the scene by fitting a data set of images taken from different viewpoints. Positional encoding in NeRF. Since neural networks struggle to learn high-frequency functions, NeRF uses positional encoding to project input coordinates into a higher dimensional space as follows. L is the number of frequencies used. This mapping enables the network to learn high-frequency details more efficiently. Neural network structure. The NeRF model consists of a fully connected network, MLP, that processes the encoded 3D position and predicts density and a latent feature vector. A separate MLP branch that processes the feature vector and view direction to predict the final RGB color. Skip connections are introduced at intermediate layers to improve gradient flow. Separate processing of position and direction means the first part of the network processes position, X, to compute density and features, while the second part processes direction, D, and features to compute color. Volume rendering in NeRF. After obtaining density sigma and color C, NeRF renders an image by integrating the radiance along a ray. The volume rendering equations are applied to a ray parameterized as follows. O is the origin and D is the direction. We compute the final pixel color as follows. Now we implement the NeRF code. Positional encoding class. NeRF class. Render raise function. Testing the NeRF model.